Hello and welcome to this video on how to create a simple machine learning classifier. Machine learning can be used to perform quite a number of tasks, which include regression, and we have previously made a video on regression. If you have not watched that video, I have left the link in the description below. Click on it and please watch the video. Then we have clustering, we have association rule mining, we have dimensionality reduction, and we have classification. Now, classification can be further classified into two main categories, which are binary classification, which involves classifying something into only two classes, that is, a positive or negative, or you can also call it true or false. And then we have multi-class classification, in which case you classify something into more than two categories or more than two classes. There exist quite a number of machine learning algorithms that can be used for classification, and they include logistic regression, support vector machine, random forest, naive Bayes, and others, such as artificial neural networks, which are more purposely for deep learning. However, in this case, I'm going to show you how to create a simple random forest classifier. And in this case, we are going to try and classify the wine quality dataset that is available in Kaggle repository as to quality wine and not quality wine. Therefore, we are going to do a simple binary classification. To start with, we import the requisite libraries. In this case, we'll need pandas for obviously loading the dataset. We'll need Seaborn and matplotlib for visualization. Then we import our classifier, and we import it from a library known as sklearn.ensemble, which is a scikit-learn library. We import the metrics for purposes of evaluating how our classifier performed. Then we import the standard scaler for purposes of standardizing our dataset to avoid outliers. Then after that, we need to import the train and test split for purposes of splitting our data into a training set and a testing set. Then you can run that particular cell by pressing Shift Enter. In the next cell, you start by loading your data set, create a variable. In this case, I'm going to call it wine, and then you use the pd.read_csv method to load your data set. In the brackets, pass the name of your data set, and then you can use the separator as this semicolon that I've used over there. After you load your data set, the next thing that you need to do is to visualize your data set. You want to see how your data set looks like so that you can be able to compare what you have loaded against what you had to see if actually you loaded the correct data set. To do so, use the .head method to print the first 5 values of your data set. And here we have a snippet of how our data set looks like. So we have the first column, which is fixed acidity, second column, volatile acidity, third column, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, and quality. As you can see here, quality has been assigned a number, but we want it to be binary, whether it is a good quality wine or a bad quality wine. And quality is being influenced by these elements that we see here, all the way from fixed acidity to where we have alcohol. So changing the levels of fixed acidity could impact on quality. At the same time, changing the levels of maybe total sulfur dioxide could impact on quality. And now we want to train a classifier to understand the relationship between all these variables and how they impact on quality. And then we feed it with our own values, and then it tells us the quality of that particular wine, or the quality of the wine based on the values that we shall feed it. Now, further pre-processing, let us understand how our data looks like by printing the shape. In this case, we see that we have 12 columns against 1599 rows. This is not a very huge data set, and therefore we expect that our model is going to train within a very short period of time. It's actually a matter of few minutes. Then we can print more details about our data, check if actually we have any null values, check the specific column details, and we can be able to see them over there. You can further use this one to check null values, and this one is known as null.sum, which basically checks whether each column has any null values. It sums up the total number of null values and then gives the sum here. In this case, all columns have returned a value of 0, which means that we have 0 null values. Now, if you look at our data set here, the column which is known as quality, you can see that it has some numbers. Here we have 5, we have 6, and we have 5. Maybe if we come here and we actually even print out the last 5 elements, the last 5 entries in our data set, you can see that we still have those kind of values. So they are not categorical in nature, rather they are unique values. But in this case, we want to have a binary classifier. In this case, for us to have a binary classifier, then we need to convert this last column known as quality into a binary column, or what you can call a categorical column. To do so, we use this method known as beans to define what will constitute a good quality wine. And in this case, we have defined some figures here, 2, then a comma, 6.5, comma, then 8. This means that a good wine ranges from a quality value of 6.5 all the way to a quality value of 8. And therefore, anything below that will be considered to be bad wine. This must be a really high standard. Then after that, we define the group names. We say that for the first here, which is 2, we want it to be bad, or anything below 6.5 to be bad, or anything above 6.5 all the way up to it, we consider it to be a good wine. Then after we do that, we want all now our data to be converted into a categorical data. And so we use the array method. We come here and we define our data set, which is wine. We define our column, which is quality. And then we want to replace this column known as quality, the values that are there, with the categorical values that we have created over here. And thus, after we do that, we print the unique values in quality. If we were to print the unique values in quality before doing this, it would have displayed for us all the values that are available in quality. Maybe before we even go further, we can go ahead and print that one. You come here and say wine, then you define the column. The column is quality dot unique. You can see that it has these unique values 1, 2, 3, 4, 5, 6. It has 6 unique values, which means that it has 6 classes. But then we want it to be just 2 classes. That is why we did this one over here. And now once we print this one, it is now just 2 classes, which are bad or good wine. Now, let us now enforce this to our labels, where we had something like 5 converted to a 0. Where we have something above 6.5, you convert it to a 1. To do that, we write this code over here. And once we run it, it will put that impact on our dataset. Let us display the first 10 elements of the now modified dataset. Once we display the first 10 elements, we can be able to see here that anything below 6.5 has been assigned a 0, and anything above 6.5 has been assigned a 1. Now we have a categorical binary classification. Now, if we try and count the values, we can see that those which have 0, that is the bad wine, are 1,382, whereas those that have 1, which is good quality wine, are only 217. Then we can be able to visualize this because, as they say, an image is worth more than 1,000 words. So once I visualize this using Seaborns, and I'm using the SNS method .count plot. Why am I using SNS method? Because when I was importing Seaborn here, I imported it as SNS. So that is the object name of my seaborn. Then I'm calling the method known as countPlot to display this count that we have over here. Then I pass in the parentheses the arguments, which is the data set, the wine data set, and the column that I'm interested in, which is the quality column. And this is the display that I have. You can see 0, which represents bad quality wine, and you can see 1, which represents good quality wine. After that, we separate our data set into a response variable and a feature variable. Then we split the data set into a training set and a set. Remember, even when you are doing regression, we also did this. In this case, we are going to use the training test split that we imported, and I'm going to split this data set into a 20% test size. That's what I've defined at 0.2 here, and an 80% training set. So if you take 100% minus 20%, remain with 80%, which is the remaining set for training purposes. Then I have defined a random state of 42. Random state simply means how well do you want data to be randomized before it is split into a testing set and a training set. Randomization is important because it makes it possible for you to avoid taking the last 20% entirely as your testing set, because the last 20% could be biased. Now, to avoid this, you randomize your data so that you take the 20% randomly. Then once you do that, you can be able to see the first 10 rows of the training set. And since we have used randomization, you can even see that their IDEX values here are coming in random way. Then the next thing that we need to do is to standardize our data. The purpose of standardizing this data is that so that some values are not so huge while others are so small. In this case, we have some values which only have 1 decimal place, while others, such as the ones that we can see over here, have close to 5 decimal places. Therefore, we use the standard scalar that we have over here to standardize this data so that it looks more uniform. After standardization, the next thing is to now create our classifier. To create this classifier, you first define a variable which will house the classifier. In this case, I have called it RFC to start for random forest classifier is equal to, I now pass to it a value, and I call the random forest classifier that we imported here. You can see it here where we imported it. After I call it, I need to pass some argument to it, and in this argument is the number of trees that the random forest is going to have. Remember, a random forest classifier is basically a combination of several decision trees, so it has quite a number of trees. So we use the n_estimators to define the number of trees. In this case, I have put the number of trees to be 200. After defining your classifier, now fit the classifier. Fitting is also what we call training. And since this one is just a small classifier with a small data set, this one takes just a few seconds. So you come here, you call your classifier rfc.fit, you pass to it the X training data set and the Y train. Then after that, you need to test the classifier. To test it, you define a variable known as prediction or pred_lfs is equal to the classifier.predict. So use the .predict method. Then you pass the testing data set. You can run that particular cell. That's taken some few minutes, but then since it's not huge, we are finished. Then you can print the classification summary or the classification report to see how it performs. In this report, we can see how our classifier was able to perform. We have the precision, we have the recall, we have the F1 score. These one are evaluation metrics that are obtained from the confusion matrix. And in this case, we can be able to see that it was able to classify the 0 class with a precision of 0.92 and the 1 class with a precision of 0.73. And when we go to the macro averaging and micro and weighted averaging, you can see that for precision, it's having a weighted average of 0.89. That is how it is performing in both classes. For recall, it is 0.90. For F1 score, it is 0.89. These are quite impressive figures. Then we can go ahead further and print the accuracy separately. In this case, we just call f from sklearn.metrics import accuracy score. Then you import the accuracy of the test and the prediction dataset. And as we can see here, our random forest accuracy is 0.9, which is the same accuracy that we have over here. So if you are unable to interpret this classification report, you can print individual metrics or individual evaluation metrics separately. So with just a small data set, I would expect it to be somewhere around 0.99. So you can improve on it by doing further modifications to the classifier, playing around with hyperparameters, and adjusting some of them so that you achieve better performance. 0.9 for such a small data set is not very good. The next step now is to try and evaluate or try and pass our own values to see how well the model would classify them as whether they are good quality wine or bad quality wine. This is especially critical because let's assume you have a winery company that is expected to maybe define the bare minimum values that they need to put for them to get good quality wine. So they have defined the fixed acidity, the volatile acidity, residual sugars, and so on. Let's assume some elements here or some ingredients here are more expensive than others. So having something that can help you make a decision is a technology that no wine company would not desire to have. Then let's come and define our own values and say, let's take, for example, the fixed acidity to be 7.3. Then the next value is volatile acidity to be 0.58. And the last value is alcohol. Let's have it as 10.0. The other values, I have also passed them there. Then we pass this, the standardizer, we first standardize it so that it is also treated as a uniform data. Then we pass it to our random forest classifier for prediction purposes. And then we print prediction. So if I press Shift Enter, it gives me 0, which means that these values that I have passed here are about to give me bad quality wine. Let me now pass a new set of values. And if I pass a new set of values here, these ones, if I click Shift Enter, they are going to give me good quality wine. You can play around with these values. Let's, for example, try and change this one from 15, because 15 is too high, something like 5. How would it affect? The wine would still be good quality, so you can cut on cost on that one. This one is 21, or if we change it to 11, the wine becomes bad quality. Oh, so 11 would make a bad quality wine. What about we keep it at 15? Still bad quality. What if we change this one to 20? Good quality wine. You can see how you can be able to play around with these values. And I believe this is something that is so good for you to learn. And this is a skill that once you have it, apart from just wine classification, you can use it in other industrial production purposes. Thank you for watching the video. Please consider subscribing to the channel, like our videos, also share them. And if you have any comments, put the comments in the comment section below.